Hello, everyone. Good morning. Thank you for taking time coming here to attend our session today morning. So I'm co-presenting here with Dimitri. So we'll be talking about how we do these durable media workflows at Netflix. And we're going to share some kind of insights from our Plato workflow platform. So the agenda today is I'll give a quick intro about Plato and a even larger Cosmos platform, and then we're going to talk about some of the salient features where we're going to share some insights about scale, developer experience, and the RPC durability, and then finish off with some learnings in the conclusion. So to get us started, so that you can appreciate the complexity that we go through in this space, I would like to present how a media processing workflow looks like. So this is a very super simplified version that I'm presenting here, where what the kind of steps involved at a very high level to take a title, make it ready for playable on the Netflix product. So this is one of the use cases that we support among many others. So here we have a title, murder mystery in this case, that is getting ingested from the studios into our systems, where we first do some inspection and checks at that ingestion phase, and which itself is a workflow. There are a lot of workflows that happen there, and a lot of optionality based on the source type that we factor in. Then there is encoding. For simplicity, I'm presenting here only the video encoding, but there's also audio encoding and text processing for different languages, and aligning the subtitles based on the transitions in the scene, and all that is all happening in that processing. So, and video encoding is one of the very complex step, and it gets even more complex, and as we support more profiles, more codecs, more device types. So if you take one particular profile, it would involve typically splitting the video, encoding it, and then assembling back. And we do that multiple times to support different device types. Then after that is done, we get to the packaging phase, where all the materials, audio, video, text is all packaged based on the target type, and DRM is applied on it. And then we deploy it to a CDN, which is Open Connect. And then at that point on, the device kind of out boundary is done, where the content is playable, ready to be playable on this product. And similarly, this is for the streaming. We also support use cases like for ads encoding, also studio use cases like dailies and many pitch to play journeys in production, and all those phases. We support many workflows in that space. Also trailer generation, all this kind of media processing is enabled through our platform. So with this, I want to present a high level about the Cosmos platform, and this is a nice tech blog. We have blogged about this Cosmos platform a few years ago. You can check that out also for a very detailed description on how we do it. So here what I'm trying to present is this red blocks here are the places where our users write their code, and they're all connected with queues. That's a durability aspect. We'll talk more. For every Cosmos, this is a Cosmos service, which a typical unit in our LAN, where it starts by users writing an API, a gRPC-based API, protobuf-based contracts. Then they write their workflow as Groovy or Java code, like workflow as code. That's that part. And then they invoke functions, which is serverless functions, to do actual media processing, and which typically takes minutes, anywhere from minutes to hours, sometimes days, to complete each function invocations. Now, that's from the user standpoint, and auto-scaling is all enabled out of the box for them. Now, if I take that and use it to create one sample H.264 video encoding service, it would look like this. If you look at the white boxes here, that's the kind of what our users would be focused on or writing, which is a video API, in this case, H.264 video API with their contract for the service. Then there's a video workflow rules that they write to orchestrate their video functions. And I'm showing two functions here, chunk and assemble, but there are more that actually come together to make this whole thing work. Now, if you zoom out to the red boxes, those are the way we come in as Cosmos platform. We provide in each layer a affordance and a platform which is fully managed, and where we bake in the durability, which we'll talk about more. So for API, there's Optimus, and for workflow, Plato platform, and Stratum is the thing that serverless platform we have in Cosmos. And for this talk, we'll focus on Plato. And also, there's another aspect where the Cosmos services can also be hierarchically composed so that there's a boundary of each Cosmos service is mostly domain specific, like we've seen before for H.264 video encoding. Similarly, there's audio service, text processor service, inspection service. Each has their own Cosmos service. And the top level Cosmos service can compose them like this, where a workflow at top level can call a lower level service, which is shown here. Also, we use a queue there for durability. And then it can also call a function directly. So that's kind of grain in which the orchestration happens at. So now, zooming into Cosmos Plato. So Cosmos Plato is our workflow rule engine. We have covered like more than a decade experience in building different generations of this workflow engines for media processing specifically. So this one we started working as part of Cosmos platform, which is from 2018. So a lot of experiences we had from prior generations are kind of baked into Cosmos Plato. So what we support, Cosmos Plato supports users to write like either we have generally stateless workflows and stateful workflows. Generally, like at the lower level, Cosmos services tend to be stateless, which means they run their start point, end point, they run to completion. And it's OK to retry since they're smaller unit. Compute-wise and efficiency is fine, actually. That's the right level at which we want to have retries. Then there are stateful workflows, which are generally more closer to business domain, which are like much higher level things, which orchestrate a lot of things. If you look at from vantage point of a top level stateful workflow, you would see like 2 to 3 layers, even sometimes 6 layers of Cosmos services all the way down. That's the longest path to execute some function. And they're generally long-lived. In the example I presented, murder mystery, if we have the title, and after a few years, Netflix want to support new device types, new codec types, new codec innovations. We go back and encode these titles again so that they're still playable on the supported devices. That's where I'm calling out long-lived. It's super important. With that brings in the complexity that we sign up for in supporting stateful workflows. And also, the retries get super expensive at that level. So due to latency and due to compute efficiency, generally the smarts put into each domain based on some hints. Generally, partial retries are preferred in that space. And for workflow development models, we support both graph-based workflow development for our media processing application developers. So encoding technologies is a team in Netflix who are the experts in all media specs, codec standards, and all. They are our biggest user, alongside studio users, these are comprised of the biggest users for Cosmos. So users can either write graph-based workflows, or they can do rules-based workflows where they react to events. And that's how the workflow, if you look back, it looks like a workflow. So generally, what I've seen like more and more after we put these two affordances, graph-based and rule-based, stateless is where generally users tend to write graph-based, since it's like manageable unit, smaller unit, and they're not long-lived. And for stateful, they prefer to use rule-based, since we want to maintain kind of in perpetuity that workflow around that title. So those are the things we support. Now we look at like a little bit of architecture in Plato, very high level here. Where like here we have Plato runtime, Plato node would look like that inside, and the red box. And it talks to the messaging queue, which we'll talk more in the later slides. And we talk to, it also uses database, Cassandra in our case, for persistence. So within the workflow engine, we have the platform components that we all build in Cosmos platform team, which we are part of. There is a workflow engine runtime, where we ship runtime extensions and workflow executors. And also, there is a workflow manager, which we ship, which is responsible for deploying or revving the user code. And then we pull in the user code, which can be graph-based or rule-based, into our runtime. And that is what we use to run the workflows. So now, I want to present actually the salient features that we want to show, the insights part here. So if we look at the previous sections, RPC is a pretty important thing. When I said like in the workflow, in media processing workflows, when a workflow invokes a function or another service, both are modeled in our land as an RPC call. So it just looks an RPC when you look at any workflow, bunch of RPCs. So due to that, like we invested heavily from beginning in making it more durable and also abstracting it as much as possible so that it looks like RPC for our users. So how do we do that? So first thing is like we use circuit breakers based on RPC abstraction. Each dependency we can observe. If the dependency A is down, then we do have a way to profile our workflows and kind of pause executing the workflows and functions that depend on that particular RPC dependency. So that's one lever we have to turn on if there is any dependency that is down for momentarily. And then other one is global circuit breaker. When there's an Amazon outage or some other network large scale outage, there's a big red button. Those are the kind of things we use. Another one is about message queues, which I've been mentioning before. So we built a homegrown messaging queue called as timestone. And this is where all the durability semantics are baked into timestone queue system. So timestone is timestone queues are ones we use to asynchronously communicate between all subsystems in Cosmos. And it is a priority-based queuing system where it's a deadline-based priority. That is, if a title that should go live in a month versus title that should go live yesterday, that is how we use to prioritize which one should be worked on first. And that goes through all the way. When I said 6 layers of Cosmos services, that priority notion is baked into all steps. And also, the timestone queues provide these affordances to like message leasing and message retries and absorbing large bursts, like holding millions of messages of backlog, and sharding, so that if there's a one large message queue, it does not have a collateral impact and threatening the whole system. That kind of things are all baked into the messaging queue, which improves durability of the messaging queue. Now I'll present how we use that RPC, how this messaging queue and RPC come together to make this RPC durable. Imagine like if a service A want to call service B, in our land, in a workflow engine, want to call another Cosmos service or call another some function. That call, if we double click into that, this is how it looks like. The red box is what we generate actually, where for every target service or target function, we generate a fully typed client from out of the box. In the client, we abstract away these queues where there's a pair of request and response queues that are baked into that. So a workflow developer who want to make an RPC call, they pull in this generated client and then make the call. It looks like regular RPC call synchronous, but it's all asynchronous behind the scenes. So when the call happens, we put like the typed message into the request queue, and then the target service, based on its processing capacity, it will pick up from the queue. And when it's done, generally they take minutes to hours to complete. When it is done, it will put back the response in the response queue. So that response will be picked up by the Cosmos platform, and it will kind of resume the caller workflow from where it left off. So that kind of construct gives us this abstracts away nicely and provides durability at a very substrate level in Cosmos. So that's how we do durability and enhance it in Cosmos. With that, I'll transition over to Dimitri, talk about scale.
Morning, everyone. My name is Dmitry. I work with Naveen in the same team, and I've been working on this platform from its very beginning. And I'll continue this presentation talking about how we scale to millions of workflow events, and these are millions per minute. So just like with every new platform, we started very small, and then we continued growing, and then we faced various challenges in the area of scale. And where we currently at is we process from anywhere from 3 to 5 billion messages a day. And we have over 50 workflows that are working on those messages. So a little bit about the nature of our workflows. They are bursty. And this is just how it works. So pretty much a studio would shoot a movie and they would upload their raw assets and then drop a message to one of the workflows and then this workflow would pick it up and fan out the job to other workflows, and those would pick up their messages and fan out it even further, and then it goes all the way to functions, and this is where we get this burst from. And there are two types of workflows that we have. Some of them are latency sensitive, and that usually means that there's somebody producing some trailer for marketing so that they could upload it to social media platforms, and they usually are expected to complete like within minutes, versus some of them are throughput oriented, and that means that we don't care how quickly they complete, but we more care about like throughput, and we want to process more within the same amount of time. So some tasks can even take weeks to process, while others are expected to complete like within minutes. And here's like a real world example. So all this various color chart lines, these are workflows and functions, and these are running messages. And you can see that easily, like some of them have like hundreds of thousands of messages processed per minute. You also can see that the traffic is spiky and bursty, and there's a lot of correlation between various workflows and functions. This is just how our systems work. And here are the pending messages, same story. Like you see, there is a burst, and it's basically absorbed by the messaging system, and then at some point it drains, and then there's a burst again. And this scale is again 1 minute. All right, what kind of techniques do we use to scale? Of course, horizontal scaling, everybody uses it these days because nothing fits into one box anymore. We're not going to focus on that. And vertical, which is very interesting. We pay a lot of attention to it, and we use multiple techniques and tricks to make it better, such as execution avoidance, caching, rules indexing, priority-based queues, priority engine, resource pools, and we'll just talk a little bit more about each of them. So execution avoidance, what does it mean? Let's say workflow receives a message, and it's a reply from its worker, and it has some data that workflow needs to store. We are going to pick this data and store it, and then we look at the message and we see also that this message has some metadata, and the metadata is saying, well, there were more messages for this project in the queue that are waiting to be picked up. And instead of kicking workflow, we go and pick more messages, and we pick up as many as we can. And once we cannot pick anymore, we start the execution. What does it mean? In some cases, it means actually a lot, because if your workflow has like hundreds of rules and in size of megabytes, this could be quite a heavy operations to even evaluate those rules. So on average, we're saving like 2.5 messages can be like grouped this way, and execution for them can be avoided. So caching, memorizing responses from execution. In our world, is quite important because let's say if you have service A and service B, and they're asking service C to perform some operation on the same asset, and it's the same operation, then we don't have to do it twice. We just serve it from cache. So rule indexing, understanding which changes in the workflow execution state would trigger which rules. Pretty much, usually what people do is they index data. We don't do that, we index rules. And our index tells us, given that this data change, which rules should I run? And sometimes out of like hundreds of rules, you only need to run 10, and that also saves a lot. Priority engine. So message priority can be lowered at runtime or increased if needed. And how priority works is like the top level workflow would set it, and then it gets propagated across all of the workflows. And engineers have an option to lower it or increase based on the work that the workflow is doing. So resource pools. This is pretty much computational resources that are allocated for certain types of jobs. And as you can see, our backlogs are quite big, and it's very easy to exhaust all of the computational resources that we have available to Netflix for encoding. And this is why we reserve certain pools, like so that those low latency workflows could proceed even there's a huge backlog of throughput-oriented workflows. Resource pools work the same way. They are set by the top-level workflow and propagated all the way to lower workflows. All right, let's switch to the next topic, and it's prioritizing developer experience. Developer experience is important, and we learned it the hard way because our engineers came to us and said, well, this stuff is unusable, it's too complex. You know, there are 3 components that you have to maintain, and it becomes a nightmare. Even with that said, we did have some thoughts in mind when we started working on this platform. We had the strongly typed data models and contracts. Everything is protobuf and gRPC, which made life easier. And then out-of-the-box support for state management. Pretty much whatever data model you define and then operate, it gets persisted by the platform and also indexed and made available for search if needed. This is something that our engineers don't have to take care about. Testing. That's also was something that we put in some effort in the very beginning. We created this frameworks, one for unit testing, which allows you to test your asynchronous workflows and verify if they're correct without going like to any queues or anything, just locally, where we mimic all these queues. And then for end-to-end test, we did the other way around. Like you just write this unit test, which looks like unit test, but actually what it does, it goes to a dedicated environment where all the workflows are running and runs this end-to-end work in multiple workflows, and then in the end you get a result and you can verify whether it's correct or not. All right, observability. We invested a lot into it. Like we have a tool which is called Nirvana, and it allows you easily get to your logs, see all the traces, view state of your projects, source it, requests, and dig through messages if you have to, find errors. So this is how it looks like. These green lines are executions, and they're called spans. Pretty much in this picture, you can see that there's an API, workflow, and a function that is being called, and there's an error in one of the spans in the workflow. And then this left bottom corner, once you click on the span, you get easy access to all the related logs that happened in this span, where you can find error and all other related data that can be useful for troubleshooting. So case studies. These are things that were introduced like later, things we didn't think through in the very beginning. So for a variety of workflows, rules, which we had from the very beginning, were quite complex. Well, imagine you have like 50 rules, and then there's data state, and you have to imagine in your head like how it's going to work. And if you introduce a new rule or change existing rule, you have to like think through like how is it going to work. Versus a graph where you just define your nodes, and then you connect them into a DAG, and that's how your workflow works. Easy to comprehend, easy to understand, and faster to develop. And then canaries is something that we added later. Pretty much it helps you with deployment confidence. Once the workflow goes to production, we create 2 instances that would host an old version and a new version of workflow. We collect metrics, and then we look at the metrics and say, well, the new version has more errors than the previous one. We probably don't want to deploy it, and that's how we limit the blast radius if there's a bug that was introduced in the workflow. And also, given that we have all those retries, most likely those messages, they will get picked up by older versions of workflows, and the workflows will resume execution. Okay, challenges. What kind of challenges do we have still? So third-party services, because our system is multi-tenant, we don't allow a lot of them. We support gRPC calls, but that's pretty much it, and people are asking for more. And there are certain considerations. You know, the system is multi-tenant. If you bring in your dependency, like it happened once, somebody tried really hard, and they had a dependency which opened about unlimited number of connections, and the system ran out of resources. Local development and debugging with the 3 components. You have to like start them individually. Sometimes you have to have open multiple IDEs for different components. That kind of sucks, so we're trying to improve that as well. And then paved path for Netflix, it's mostly focused around the synchronous microservices, where you have a Spring Boot application that runs in a Docker container, and the considerations for asynchronous things, not much of them. And they progress on their own, we progress on our own, but our users are asking, well, can we have this kind of paved path experience where it's super easy and very, user-friendly? Yeah, that's another target that we have. All right, so in that leads us to conclusion, and the conclusion is like building this reliable, distributed, asynchronous media processing platforms is complex and challenging, and you have to consider multiple aspects like reliability, operability, scalability, testability, developer experience, and quite often improving one takes away from another. And your job as a platform developer is to maintain this acceptable balance where everything works and everybody is happy. And that's the hardest job in the world. All right, Q&A. We will be available after the presentation, so please stop by and ask all the questions that you have. And that's it. Thanks for your interest in how we solve these kind of problems at Netflix.